ladies and gents, let's review factoring cubics. So as you learned in Algebra 2, factoring a cubic is actually a pretty tough proposition. Unlike factoring a quadratic, a second power or second degree polynomial, factoring a cube really only happens when the cube takes a very particular form. And that's what we're going to review today. Just really quick, 3 different methods if your cubic takes one of 3 very particular forms. If it doesn't take one of these 3 particular forms, we're going to have to use a different method to extract the roots or to at least rewrite the function. Much in the same way, like if you can't factor a quadratic equation, like you might have to turn to the quadratic formula. Now there is no cubic formula, at least not one that's going to be useful to us at this level. So we're not going to explore that. So we're going to hope the cubic functions that you're being asked to factor follow one of these 3 different methodology forms. So let's just jump into it so you don't have a lot of time at this station. Let's get to it. And so the first form, the first special form that your cubic might take, takes a form of what we call a sum or difference of cubes. And so I'm going to zoom in here a little bit. And so what this means is that your cubic function is missing the 2 middle x terms. So it doesn't have an x squared, it doesn't have an x. It just has the x cubed and then a c, a constant term at the very, very end. Now if you look at these 2 formula, the sum of cubes and difference of cubes, it does take one particular tactic that all these methods basically do, which is to extract a binomial term, in this case like a plus b, and then reduce the rest to a quadratic, which is a square term. And so the hope is, like, once you extract it down to a square term, your Algebra 1 or Algebra 2 take over, and then you're able to deal with this quadratic portion of the cubic using methods like quadratic formula, just regular factoring. But let me show you a couple examples of what I'm talking about might make more sense. So here's the first thing you really need to do. You need to make sure that your quadratic is in this form, missing the 2 middle x terms, just a cube, and then a number that's being added or subtracted. And then you want to take a second to realize or to determine if this trailing constant term can be rewritten as a cube. In this case, it can. This is actually going to be 2 to the 3rd power. And so it would be useful before we actually apply this formula to look at this function as x cubed or 1x cubed plus 2 cubed. Now the reason we want to do that, and of course you don't really need this one, because it follows this formula really, really well. So if you look at like this a value in the formula that occurs here, 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 and here, that's going to actually be the term that's being cubed first, which is going to be the x. And again, looking at the formula, if you look at the b term, that's going to be this 2, and that's the same b that occurs there, and then in the middle. And so really our job is to use this formula as a guide, and so we can rewrite the function. And so x to the 3rd plus 8 is going to turn into the quantity x plus 8, x plus 2. It's going to turn into quantity x plus 2. And again, following our formula, it's going to be a squared, so that's going to be x squared, minus a times b, so that'd be minus 2x, plus b squared, which would be 2 squared, which I'll just write as a 4. And so we're just following our sum of 2 cubes because we notice that we have a cube plus a cube. In this case, x cubed plus 2 cubed, because a can be written that way. Now from here we have a known 0, one that we can extract actually really quick. So this tells us at least one of our zeros is going to equal negative 2. And then it would be our job to take this quadratic and factor it, use a quadratic formula to find the other zeros of this cubic. And remember, since it is a cubic, since it is a 3rd power, we're going to have 3 cubes, we're going to have 3 roots, that we can list. But I'm not going to take the time to figure out the quadratic part. That's for another station. And so here we have x cubed plus 1. So again, this does take the form a cubed plus b cubed, where a in this case is going to be our x, and b in this case is going to be our 1. And so we bring the formula back up. So it's going to be a sum of cubes. And so we can write this a plus b, in this case x plus 1, times the quantity of a squared, which would be x squared, minus a times b, so that'd just be minus x, and then plus b squared, which will be 1 squared, or just 1. And again, we have one really quick 0 here that we can extract. That's going to be x equals negative 1, because of course that's the value that makes the term 0. The 0 is at the function value. And then it'll be your job later on to find those other 2 using whatever quadratic factoring method that you can. Because again, the sum and difference of cubes, all these quadratic factoring methods is going to somehow reduce the cube down to a binomial term times a quadratic, and then we let our Algebra 2 take over on how to solve the quadratic. Now there is a difference of cubes as well, and this is going to be used in the case where the constant term is being subtracted from the x cubed term, but our methodology is the same. Now the first thing you probably want to do is realize that it's a cubed can again be written as 2 cubed, and so that's really 2 cubed minus x cubed. Of course, that's the same as 1 cubed. Now we probably want to take one more step and realize that we can kind of partially factor out the 2x, and that's that term cubed minus 1. And so when we go to rewrite this into our form, our a is going to be the 2x, and our b is going to be the 1. Now note the formula here has minus b, and so we're going to take the b just to be the 1 value. We're not going to mess with the negative in that. And so our a value is going to be 2x, and our b value in this case is going to be 1. And so our form, we have a minus b, so that'll be 2x minus 1. A squared will be 2x squared, so it'll be 4x squared here, plus ab, so that'd be plus 2x times 1, which will just be a 2x, plus b squared, which will just be 1, because 1 squared is, of course, 1. Which gives us a really quick 0 here. That's going to be at least 1/2. And then then you have to use whatever quadratic formula, factoring, whatever have you, to deal with that quadratic piece. Okay. So here we have another difference of cubes. So of course we have x is going to be our a term. 27 is the same thing as 3 cubed. And so we can look at this as our a term being x and our b term being 3. And so if we're going to write this as a difference of cubes, this factors into a minus b, so x minus 3. A squared will be x squared. Add the two, or multiply the two together and add it, so that's 3x. And then add b squared, which will be 9. Okay. So again, we have one quick 0 at 3. And then we'll use whatever quadratic methods to find our other 2. Because of the cubic, we should have 3. Okay. So that's method 1. So that's just if your quadratic happens to take this form, where it's a cube term cube term, then no x squared, no x, plus or minus a constant, you can use the sum of cubes to actually do the factoring. The next method is a kind of interesting one. We're going to be factoring by grouping. Now in the end, again, what we're trying to do is to take whatever cubic we have, reduce it to a quadratic. But what we're actually going to do is look at this cubic, and it does have to be equal to 0. But we're going to look at this cubic kind of in 2 parts. So we're going to have this part here that has like the x cubed and the x squared, and then we're going to have the second part that has the 9x and the minus 3. Now what we're going to do is look at each of these 2 parts and partially factor out each, with the hope that we're going to partially factor out from each the same term. Let me demonstrate what I mean. So if I look at the 6x cubed minus 2x, I should notice that there are 2 common things I can factor. One, I can factor out a 2, because a 2 is both a factor of 6 and 2. And the other thing I can factor is an x squared, because both terms have at least an x squared. And so if I build this as a distribution problem, extracting the common 2x squared, 2x times some number is 6x squared, or cubed, excuse me, that's going to be a 3x. And 2x squared times negative 1 is going to give me this negative 2x squared. Now, completely separately, I'm going to now deal with a 9x minus 3. Now, what's in parentheses actually has given me a clue to what I'm looking for. I'm looking for a 3x minus 1 term. And so hopefully what I get to factor out of this pink term will give me a 3x minus 1. If I look at the 9 and the 3, that's going to tell me I can factor out a 3. Now both terms don't contain an x, so I can't actually deal with that. But what I can do is now go ahead and build this distribution problem. So I have 3 times some number gives me 9x. That's going to be 3x, because 3 times 3 is 9. 3 times x gives me just that x. I'm sorry, no x times x gives me that x. And then 3 times a negative 1 gives me negative 3. Now this is of course equal to 0. But what I wanted to happen actually did. So let me re-highlight here if you didn't quite catch it. And so here I have this term that's 3x minus 1. Here I have this term that's 3x minus 1. So that's going to become one of my 2 terms. So I factored separately. Now I'm recombining it to a single multiplication problem. So 3x minus 1. And then I'll take these 2 terms separately and combine those to make another term. So that'd be 2x squared plus 3. And so I accomplished what I wanted. I've taken this cubic and I've reduced it down to a binomial of degree 1 and a quadratic. So right away I get 1, 0. So this tells me I have a 0 at x equals a third. And then again, I'll have to use whatever quadratic methods I have at my disposal to try to extract the other two zeros from that quadratic. And so again, like the whole point is I'm trying to take this cubic and reduce it back to a quadratic. Let's do a couple more examples. Let's look at this guy here. Now what's weird about this one is I have a 28 on the right. Now that's not really a big obstacle. What I can do is just subtract 28 from both sides and leave it on, and bring it over here to the left-hand side so I can actually factor by grouping. Just like before, I'm going to regard this to be in two parts. Now your polynomial does have to be well ordered, meaning it has to be in order of degree. So those two become one group. This will be the other group, and I'll try to factor these separately. Common term. So here I have a 3 and a 7. There's not a common number I can pull out, but this has 3 x's, that has 2 x's, and so I can factor out an x squared. So what's left in the orange group should be 3x, because 3x times x squared gives me 3x squared. And then I'll add 7 to that, because x squared times 7 gives me 7x squared. Now factoring completely on the pink group, separately, I don't have a common x because not both terms have an x, but I do have a 12 and a 28. So what I can factor out would be something like a minus 4. So if I take minus 4 times 3x, negative 4 times 3x will give me this negative 12x. Negative 4 times positive 7 gives me negative 28. And that's still equal to 0. Now if you look, I have the common 3x plus 7 in both places. So common 3x plus 7 becomes a term by itself. And the terms that I'm multiplying by, x squared minus 4, again become a term by itself. And so again, I've accomplished taking this cubic function, this cubic polynomial, reducing it down to something of degree 1 and a quadratic. So I should be able to extract my zeros actually very quickly. So 3x plus 7, gives us a 0 at negative 7/3. And x squared minus 4, actually it's a really easy one to deal with. That's going to give me one at negative 2 and positive 2. And so I went ahead and did that because that was quick. But if you didn't see that, you could always use quadratic formula, factoring, whatever you have, to find the answer. Let's do one more of this type. And so we have well-ordered polynomial. There's my group 1. There's my group 2. So now we go to factoring each one in groups. Here we actually do have a common coefficient of 4, and then we can pull out an x squared. So now let's build our multiplication term from that. 4x squared times x will give me 4x cubed. 4x squared plus 4 will give me 16x squared. Now to the pink group. Here we actually just have a plus x plus 4, and so this is going to be a little bit weird, but if you notice, like I have the x plus 4 term, so I want to try and duplicate it, so I'll rewrite this as 1 times the quantity x plus 4. So now pulling our common terms together, x plus 4 occurs in both, so that becomes one term. We have the 4x plus 1, or excuse me, 4x squared plus 1, and that's going to be our second term. So we have 1, 0 very quickly. That's going to be x equals negative 4, and then use whatever you want to solve that quadratic. It tends to be a little bit more difficult, and so I'm going to actually just hold off there. Okay. So that's method number 2, factoring by grouping. Let's talk method number 3, which is just going to be actually some common terms. So in the first two, the whole point was to get it back to like a quadratic where we're comfortable trying to find those zeros. So that's what's going to happen in this one as well. Is that this one's going to be a little more straightforward. Here we're just trying to find a common term to rip out. And so again, just like the other methods, it's not going to work for every cubic, just cubics that follow a certain form. And so if we look at 6x cubed plus 21x squared plus 15x, what we can notice is that if we look at the coefficients, 6, 21, and 15, we can pull out a common 3 from each one. And if we look at the variables x cubed, x squared, and x, we can pull out a common x from each one. And so now we'll build the factor that goes with 3x. And so we're going to ask ourselves 3x times what number is going to give us 6x cubed? That's going to be 2x squared. 3 times 7 will give us 21. 7x gives us that x squared. And then plus 5 gives us that 15x. And so we've accomplished what we wanted to accomplish. We reduce that cube back to a quadratic, which gives us one really quick 0. 3x is 0 if and only if x is 0. And then again, using whatever method we have for quadratics, you can extract the other two from this quadratic. And so the point here is that we're looking to hopefully pull out not just a common coefficient, but a common x variable as well to get that cubic or whatever have you back to a quadratic. Let's look at another example. This one's a little bit weird because I'm starting with a quartic. We actually have a fourth power one. That's not going to change our approach though. I mean, we're going to look at the coefficients first. We have 3, 9, 1, 3. Well, we're out of luck. We don't have any common coefficients we can pull out. But if you look, every term has an x, which gives us some hope that this will actually work. That tells me we can pull out a max of an x each. And then now we're going to backfill the factor. And so we have x times 3x cubed. That's going to give us our 3x to the fourth power. X times 9x squared will give us our second term. This will be plus x for the x squared and plus 3 for the 3x. Now, here we pulled out an x, but we still have a cubic in the middle. And so here maybe we can apply our grouping method from the previous example, where we look at this as two separate groups and try to extract another common term. And so this x from here carries. And so we have 3x cubed plus 9x squared. Well, we can pull out a 3x squared out of both of those terms. That will give us a x to get 3x cubed, and then a plus 3 to get 9x squared. Let's move to the pink group. Here we actually have the x plus 3 that we really want, and so I'll just pull out a 1 and regroup this as x plus 3. And so in our final form, we have x. We have the x plus 3, and we have 3x squared plus 1. Now, if you remember the rules, we should actually have 4 roots. We have 1 here immediately at x equals 0, and that gives us x equals minus 3, and then the other two, we'll have to deal with that quadratic to get them, which again, I have to focus on this video, so I'm not going to deal with it right now. Okay? Let's do one more quick one. All right, so we have 3x to the fourth minus 24x. So immediately, hope we notice that we have a 3 and a 24, and that means we can pull out a common term of 3. And then we have an x to the fourth and an x, which means we can pull out a common term of x. And so now when we're going back to factor, 3x times, let's see, x squared is going to give us, that's squared. 3x to the cubed is going to give us 3x to the fourth, and that should be minus 8 to give us 24x, because 3 times 8 is 24, and the x is going to carry. So here we didn't quite accomplish getting a quadratic. We did get a 3x, but if you notice maybe the method we started with, we can actually use in this case, difference of cubes. We can use a difference of cubes to factor this cubic part. If you forgot the difference of cubes, let's go back up to the top. And so the difference of cubes is going to be this formula right here, where if we have a difference of cubes, we can rewrite it as a minus b as our binomial term, and then our quadratic term will be a squared plus ab plus b squared. Okay, so let's go ahead and grab this. Let's go back down to a problem. Okay, here we go. Okay, so our difference of cubes is going to be a minus b times a quadratic a squared plus ab plus b squared. So for our x cubed minus 8, please recall that we can rewrite that as x cubed minus 2 cubed, meaning in this particular case a is going to be x and b is going to be 2. And so we can rewrite this as 3x, which we've been carrying the whole time. A minus b, which would be x minus 2, and the quadratic will be x squared plus 2x plus 4. Okay. And again, the point was to get to a factorable quadratic, or at least a solvable quadratic. So we have some quick zeros here. We have x equals 0 from our first term, because 3x is 0 if and only if x is 0. We have 2 for our second term. And remember, this started out as a fourth power, so our quadratic should give us the other 2. Right? So guys, I know that was really, really quick, but you don't have a ton of time here. So just a really quick review. If your quadratic follows certain forms, you have different ways you can deal with it. If it's just a cubic term plus a number, you can hopefully try to find the sum or difference of cubes. If it's not, if it has all the terms, you can try factoring by grouping. And the factoring by grouping is to, in a well-ordered polynomial, take the first 2 terms, the last 2 terms, and try to extract the same binomial from each. And hopefully you can regroup that to be a binomial times the remaining quadratic. If you have common terms that you can pull out, period, especially if you see an x in each term, you might want to try straight up common term factoring to get it reduced to a quadratic. I know that was fast, I do apologize, but that's just a really quick review of some Algebra 2 stuff. So this should be enough to at least get you started on those problems.